You're a great mind.
Alright, we're looking at slope fields today. And that's what it is. It's just a field full of slopes. So we're going to go in here and fill this thing up with slopes. And where is it we get slopes from? The derivative. And what is it we have up there? The derivative. What else is it called?
Equation.
Differential equation. Okay? So that's what's going on. So, what we're going to do is, for each one of these spots, we want to figure out what the slope is at that spot, and then put a little tick mark in there that represents the slope at that spot. Okay? So, let's start. Well, it'll make more sense once we have it.
Okay.
Let's start with this bottom right point. What's the ordered pair of this bottom right point?
2 negative
2, negative 1. So, what's the only thing I can plug into my derivative though?
2x.
X. So if I plug in 2, I get a slope of 1. So I come over here, I put a little tick mark that has the slope of 1. Move to the next point. What's my ordered pair of the point above it? 2, 0. What's the only thing I can plug in again? 2, which gives me a slope of 1. What about the other 2 spots above it?
There's still some.
They should still have a slope of 1, so I can go ahead and put that in there. That's got a slope of 1. That's got a slope of 1. Alright, now the next one, ordered pair down here would be 1, negative 1. What's the only thing I can plug in? 1, which gives me,
0.
what does the 0 slope look like? Flat.
What the heck is this?
Oh, I didn't know that.
You need a pencil?
What is
this?
Eighth grade.
A pencil. You need a pen?
It's a eraser.
Can I borrow a pencil?
Alright, so what about everything above that? It's also going to be 0. Alright, so what about the next ones? I'm plugging in, what am I plugging in? 0, so I get a slope of negative 1. So these look like negative 1. What's the question? Alright, so what x value is the next ones I'm plugging in? Negative 1. When I plug in negative 1, negative 2. So here's what I do to get a negative 2. To negative 2, it's down 2 and over 1, or up 2 and over 1 to the left. So I keep this in mind, and I try to draw a tick mark that would take me to that point. That's how I figure out what my slope is. So on the next one, I go over 1 and up 2, draw my mark, and it gives me that. On the next one, I can actually go down 2 and over 1, so I know that one's there, and down 2 and over 1 again. That's there. But what has to be, when you don't have to be extremely accurate, but what has to be true about a negative 1 slope and a negative 2 slope? Negative 2 has to be steeper, so you've got to make sure you make a negative 2 slope steeper than a negative 1 slope. Okay, and then for the last one, what x value am I plugging in? Negative 2, which gives me a slope of negative 3. So I go over 1 and up 3. So I'm looking at about that spot right there when I make my slope. And again, the negative 3 needs to be steeper than the other ones. So there is my slope field. That's it. That's it. What does this slope field look like? That is. What function does it look like? Looks like a parabola. Okay, and let's see why it looks like a parabola. Because if I solve this, what do I need to do to solve this differential equation? Get dy equals x minus 1 dx. I integrate, I get y equals x squared over 2 minus x plus c. So what is this function?
That is what is
It is. So what's the shape of it?
that?
It's a parabola. So that's why that thing looks like a parabola. So what this is it represents the tangent slope at each point on this grid. So if I was going through any point on there, I know what the tangent slope should be. Now, how many solutions does this represent right here?
All of it.
So an infinite number of solutions. Why does it represent an infinite number of solutions?
You plug in that.
Because of this
See,
c. Since that constant just represents a constant, I can put any number I want to in there, and it'll give me a different function. So that's why it represents an infinite number of solutions, and that's what the slope field represents as well. Okay. Now another thing we need to be able to do is they may ask you, what does the function, the curve look like that goes through the point 1, 1? So I want to use my slope field and the fact that my curve has to go through the point 1, 1 to draw an estimate of what that function would look like. So I go to the point 1, 1, which is right here. Okay, and what has to happen if I'm sketching a curve that goes through that point? What does that point have to be?
tangent to that.
Say it again.
Tangent to that.
It has to be tangent to that. So what is my slope there? 0. What usually happens at places where we have 0 slope? A minimum or maximum. So what do I have at that point just by looking at it? What do I know is there? A minimum is there. I know a minimum is there because of the shapes of my tangent slopes. So as I move to the right, what does my sketch have to do? It has to go up. It has to match these. So it's going to go up that direction. And what happens on the left side? It has to go up the other direction. Okay, so if it went through that point, that's what it would be. So they might say, sketch it and then give me an estimate. If x equals 0, what does y equal? So what's the estimate for what y equals if x equals 0 and it goes through the point 1, 1? About 1.6, 1.7. Because my x value of 0 is here. And it intersects right there, so my estimate would be about 1.6. Okay? So we can use slope fields. If they give me a point it goes through, I can sketch it, and then I can estimate another value using that sketch. That's what's going on with these. Now, Hunter recognized these slope fields and says she has seen them before. Has anybody seen a slope field or something similar to these slope fields? Justin?
I don't know where I've seen it from. I just recognize it.
Okay.
I remember seeing something like this.
Anybody seen anything like this on TV? No? Alright, we'll let you think about it. Come back to it later.
Is it population?
No. Moving on to the next one. Dy dx equals 1/2 y. Dy dx equals 1/2 y. So we want to find this slope field. So I'm going to start down here in the bottom right again. My point is 2, -1. And I want to plug in 2, -1. What's the only thing I can plug in though? -1, which gives me -1/2. So -1/2 would be about there. Okay? I'm aiming for this point right here when I draw my slope. Why am I aiming for that point?
That's 1 over 2, 3 over.
Yeah, that's 1 up and 2 over, which gives me a -1/2 slope. Okay, on the last one, we had several slopes that were the same. What slopes were the same on the last one? The vertical slopes were the same. Are any slopes going to be the same on this one? The horizontal will be the same. Because the only thing I'm plugging into this is the y value, so all of my y values will have the same slope. So again, for the next one, I'm aiming at this point. There's that. For the next one, I'm aiming at this point. This gives me that, and then these two, I'm just doing my best. All right, so we move up. What's my next y value I want to plug in? 0. What do I give with 0? I get 0, which is another horizontal slope. So there's that. Okay, my next y value is 1, so we're dealing with 1/2. So I'm going to start over here on the left. I'm going to aim at that point right there. There's that. And I'm going to aim at this one. And I'm going to aim at that one. And then do, well, this one right here I can aim here. And this one I can aim here. So there's those slopes. And then what's my next y value?
2.
2. So if I plug in 2, I get a slope of 1. So there's that. So on this one, they might say we'll use let's use 0, 1 on this case. So let's say we wanted to draw a solution that goes through the point 0, 1. Anybody want to go up and draw it? Nobody wants to draw it? There's.
I'll draw it.
You'll draw it? Alright, let's go. You gonna draw or not? Samuel, you wanna draw it?
Maybe.
Good.
You're done?
No hurt trying it.
I was sitting here talking on this going on the moon for a peaceful life.
I wonder.
Did you feel like you answered the question? There's 3 questions, dude.
Pretty close. I'll take it.
That's what I would do.
That's what you do, drawn. So definitely has to go this direction. And as I move to the left, she got pretty close. What does it have to do? It's got to flatten out because of these 0 slopes. So that would be a solution. So they might say, if it goes through that point, and I tell you that x equals 1, what's the estimation for the y value? What would it be?
1.5.
Yeah, 1.5, 1.6, somewhere in there. If you get the ballpark, we're going to be happy with it. Okay?
Wait, what did you say?
I said, if we drew it through 0, 1, and if they said, what's the y value that goes along with the x value of 1? So I go to the x value of 1, it matches up about right there. That y value is about 1.5. So we would get 1.5. Anybody want to find out how close we were?
Yeah.
Yeah.
I'm kind of curious.
Okay. So we're using the point 0, 1. And let's solve this differential equation. What do I have to do to solve this differential equation? Divide by y, so 1 over y dy equals 1/2 dx. So we integrate. What do we get here? Natural log absolute value of y over here. 1/2 x plus c. Now what do? Plug in 0, 1. So natural log of 1 equals 0 plus c. So that means c equals 0. So I'm just looking at this. And now what do? E. And do I want the plus or minus? I want the plus. You understand why we want the plus?
No.
Because if I stick 0 in here, I've got to get a 1 out. So that means I've got to be positive. All right, and we were wanting for the x value of 1, so that means we're looking at e to the 1/2. So we need to figure out what e to the 1/2 is. Let's see how close we got now. So e to the 0.5 gives me the actual value is 1.648. Oh, we were fairly close.
Good job.
Okay. All right. Now these first two we could solve using different. We could separate and integrate and solve them. Now this last one we cannot separate this one. Why can we not separate it?
Because they're mixed.
Because of that addition and subtraction. I cannot separate these two. So in this case, the only way we can do it is to graph it and then sketch the curve and then do the estimate. So
Will a question ever ask for an estimate? Or you just
all right, so let's start down here at the bottom. So I have the point. I've got the point 2, -1 down there at the bottom. Now this time, it's going to be a little bit more tedious because this time what has to happen? I got to plug both of them in. So I'm going to plug -1 in and 2 in. So that's -1 minus 2, which gives me a slope of -3. So I'm going to aim for this point right here when I draw my slope. So there's a -3 slope. Okay, then let's move up. The next point would be 2, 0. So if I plug in 2, 0, that gives me 0 minus 2, which gives me a slope of -2. So I'm going to aim at that same spot. There's -2. Alright, then we've got 2, 1. Plug in 1, I plug in 2, which gives me -1. Anybody seen the pattern?
Yeah,
It's the same spot.
Right, what's happening to my slope? It's increasing by 1. So, but yes, as Brady said, we're still aiming for that same spot. So what's my next slope going to be? 0. We're still aiming for that same spot. So there's that. All right. Move down to the next one. What's your guess on that? What that one's going to be? -2. So if I plug it in, -1 minus 1 gives me -2. So I'm aiming for this spot right here. There it is. What's the one above it going to be? -1. Still aiming for that spot. The next one's going to be 0. Still aiming for the same spot. And the next one? +1. Still aiming for the same spot. Alright, anybody see another pattern?
Hit the
There's
horizontal,
a
like the diagonal.
Diagonal. So what's this one going to be?
Horizontal.
It's going to be horizontal. And this one also. This one,
Which one?
this one right here. What should this one be? Should be 1. What about this one right here? Should be, I mean, yeah, this one was -1, so this one's 1. What about that one? 2. Okay, this one?
1.
I was at 0. 0's below it, so this one's got to be 1. The next one's got to be 2, and the one above that has to be 3. What am I starting with here? I'm starting with 1. The one above it? 2, then 3, and then 4. So, let's say I want the solution that goes through the point 2, 0. Anybody want to come up and draw the point, the solution that goes through the point 2, 0? Two, 0. So we want to go through the point 2, 0. Right here. Nobody wants to come draw it? What has to be going on the right side of it?
Going out. Yeah.
It's got to be going this direction, correct? What has to happen on the left side? It's got to go up, and we've eventually got to get to a high point, and then we've got to come back down, which looks like that.
That's where I've seen this. Is it okay, sorry.
So I might ask you, if x equals -1, what is the y value at that point? And what would you tell me? If x is -1, what's the y value that goes with it? Negative point, let's say -0.4. So -0.4. So we drew our slope field. We drew a particular solution that goes through it, and then we use that solution to estimate a y value given an x value. Okay? That's how slope field is.
How do you know,
How do I know what?
like, I just don't understand how you're figuring out that's what the curve will look like.
Well, that's what the slopes are for. Okay, I know it's got to be shaped like this, and because of this, horizontal piece right here, I've got to reach a what? I've got to reach a maximum. So I've got to reach a maximum somewhere in here, and then because of these diagonals right here, I've eventually got to get to the point where I'm going that direction, and in order to get to that direction, it's got to.
So is it just
Curve.
following those dashes?
Yeah, that's all you're doing. You're using your slopes to use that as a guide to draw your solution.
I'll be using the dashes above that.
Correct.
How do you get
Because -1 is right, -1's right here, so my solution would be about right there, which would be a negative value or -0.4 value. So where have you seen it?
My dad had me take a shooting class, and in it we did probable trajectory.
Okay.
And they used this. I didn't understand what it was. I mean, I got the concept, but
Now, Hunter says that it reminded her of something when she was watching the news and watching the weather part of the news. And it showed you like what the winds are doing or which way the weather's going to go. And that is actually a slope field that shows you if it gets in this current, the wind's going to go that way or whatever. So that's what's going on.
This is the first thing I've ever seen Catherine's relate to life.
That's what when you see those weather patterns, they're using slope fields. They're using a slope field to project where the weather's going to go, and they've got to draw a particular solution to it, and that tells them where the weather's going to go. So that's what's going on there. Okay, now I want you to notice something. What was going on with our first slope field? What was special about it? All the vertical slopes were the same. Why were all the vertical slopes the same? Because my differential equation only involved x. What was going on with the second one? All the horizontal ones were because my slope field only involved y. And what about the last one? Were the horizontal or the verticals the same? No, and that's because my differential equation had both x and y. Okay? Because when we come back, the next time we work on this, they're going to give me a slope field, and from this slope field, I'm going to match it to some possible differential equations. Okay? And that's one thing we're going to use. Are any of my vertical slopes the same? If they are, then I know my differential equation has to be in terms of x. Now I ask myself, are any of my horizontal ones the same? If they are, then it has to be in terms of y. Then if no horizontal or verticals are the same, I know it has to be in terms of x and y. So that's why we needed to notice that.